A very good evening to all the students of semester 4 in computer engineering. Welcome to semester 4. My name is Professor Atul Oak, and maybe I'm your teacher for this journey of microprocessor. I'm there with Vidyalankar from almost 14 years, 14 years, and 20 years I'm teaching academics, professional experience in all. And I feel that this subject called microprocessor is a very fundamental subject for semester 4 and your entire career. You may go to software, or you may go to analytics, you may go to ML, AI. Somehow you will require all the background of this subject. I hope many of you know me, because in semester 3 we have made for computer organization and architecture, that is COA. Some students I can see, in fact many I can see from the list, they were there in COA. And this microprocessor is one step after COA. So it is always better that in this initial 1 or 2 weeks, you read about fundamental concept of COA, because on the top you are studying microprocessor. No doubt I will be starting with absolute fundamentals. I'm not going to assume that you are well aware about computer organization or programming, but it is better that if we go through, that will be a great help. Okay, I will start my presentation. I think I introduce and now time to move. So I will start my presentation and sharing of PPT. Just give me. Let's check my screen is visible to everybody. There are around 35 plus number of students in this discussion.
Visible, sir.
Yeah, that's great. Thank you. Let me adjust my background also and my icons also, so all will be well. Okay, now everything is well set, and we are ready to start. Okay, so once again, a very good evening to all the students, and welcome to semester 4 typically in microprocessors. Here we go. Let's start with my introduction. Already I was talking for about 2-3 minutes, but what you see on your screen is my professional and academic qualification. I always believe that it starts with the teacher, and students must know about background of the teacher. So this is my academic and professional qualification. I teach domain of system architecture from almost 14 years with Vidyalankar, and in all 20 years. And in this domain, I teach different subjects like microprocessors for you, microcontrollers, computer organization, like in last semester, I taught embedded systems, operating systems, database management system, till IoT. This all domain is system architecture. And it needs rigorous programming. System architecture requires lots of programming. So I teach some programming languages starting from C to C++, Java, advanced Java, assembly, and Python. So this is my area of teaching and research, because my research is in IoT. This I already said in initial 2 or 3 minutes. Now let's talk about your subject. Your subject, CSC 405 microprocessor, is a complete subject, 80 marks theory, final exam, 25 marks for experimentation, the way you do, average of IA1 plus IA2 divided by 2, and that total is 125, 3 credits for this subject. And these are the modules in your subject. There are total 6 modules, and my favorite quote, race against time, that is what we will be doing also on these 3 months, I will say, or little less, because it is a complete package of microprocessors from 1976 chapter 1 till 1999, or I will say 2000. This entire package you are going to study starting from 8086, going to 80386, going to Pentium. And that is why I said it is a race against time, my favorite quote. But anyway, we will try to win that. Though there are 10 sessions officially, you will get lesson plan. It is already been shared with office. We may go a little extra because within 10 sessions, it will be slightly difficult. So maybe 2 sessions we can go ahead, and we will try to complete this package called microprocessor. And very good reference you can start referring right from day 1, that is 8086 microprocessor and interfacing used by Douglas Hall. This is a very standard textbook. Ebook is also available, but you need to search you have to take more efforts. And very nice textbook to start 8086 microprocessor. Even when I did my engineering, I referred Douglas Hall for studying microprocessor. And normally in classroom, I always give notes, my own notes, well organized notes I used to dictate. Now these notes I have converted into proper soft copy format. They will be made available to you. Typically module 1, 2, 3, 4, these notes are ready and they will be shared with you in PDF. I will also dictate some important points other than those standard notes. They are all prepared by me. Module 5 and 6, those notes you will get separately because that we have to make as per your requirement. This all is about planning of the subject, how subject looks and how we are going to go. We will go sequentially, 1, 2. Today we will be starting with chapter 1. Now let's see what you will need. You will need one notebook. Okay, my dictation will be there. I will be giving you the notes other than what I'll be providing you. Okay, because I said that my notes I have converted into PDF and they are available. Proper modules are available, 1, 2, 3, 4. It will be shared with you. But other than that, I will be giving some more supplementary material. For that, you will carry one notebook every Friday, 5:30 onwards. And there will be 2 parts. One part will be for concepts. And second part will be for programs. Because in this subject, you are studying assembly language programming. And that we will be keeping in second part. And all concepts we will be putting in part 1. That way, this notebook will look like. Notes, I already talked. Reference, I already talked. That completes initial 10 minutes. Prerequisite, I said Sem IV COA, that is DLCOA, that was the subject. Now let's see what is a plan for session 1, because now we are going to start officially about microprocessor. What's the agenda? Let's see. I will be talking about myself, subject, and general plan. I did. We will bring microprocessor in our discussion, the subject title. We will understand what is a bus and what are types of buses. We will slightly go into a memory called RAM. We will bring 8086 microprocessor in our discussion. We will talk pipelined architecture of 8086. And we will start architecture of 8086 processor. This is the big plan for the day. Let's see how much we will able to complete. Okay. If you are ready, if all is well, if you can see me, if you can see my PPT, if I am audible, please type YES in chat box. I call YES as magic words so that I will come to know all is good. Okay, I can see a lot of YES in chat box. Looks great. And time to start with the microprocessor. Okay. Let's go ahead. I always teach through question answers. Okay. It's my normal habit that I ask lots of questions, and through that I go on teaching. You can answer through chat box, which is most favorite because it's like a silent tool. Or you can also use mic. You can unmute and you can answer my question, but one by one, because otherwise there will be chaos. Let's start. Okay. There is a question. Question is, what is a computer? You are from computer engineering. You are in semester 4. Proudly, you will say after 2 years that I'm a computer engineer. So the question is, what is a computer? Because computers are everywhere. What you see is a desktop computer, and what you see is a Raspberry Pi. So this is basically normal desktop computer, and this is a Raspberry Pi. So my question is, what is a computer? Yeah, anybody who can answer?
Computer is for storing and processing data in binary form.
Okay, that's a good answer. Anybody else?
It includes hardware and software parts.
Fantastic. Agreed. Any other answers? Your contribution is a key. Understand? We can take some extra time, extra sessions, but focus is on very good understanding. Okay, so go ahead. What is a computer? That is the question. You're from computer engineering, so probably you must answer it. Okay. Let me answer that question. Computer is an electronic machine which processes the data very fast. I repeat, computer is an electronic machine. It is an electronic machine which processes the data very fast. Out of curiosity, if you open this computer, typically desktop, you will find lots of ICs, integrated circuit. So we say it is an electronic machine. And you can just add some numbers, arrange numbers, prepare merit list for your IA1 or IA2, max to mean. That all is a processing of the data. So computer is an electronic machine which processes the data very fast. And like I said, computers are everywhere nowadays. It can be a simple banking type of application. Education, what we are doing is through computer. I'm using my laptop. You are using your laptop, maybe mobiles. Mobile is a computer nowadays. And almost everywhere in industry, like manufacturing, maintenance, and so on. My question is, what is the minimum requirement for working of a computer? We defined what is a computer. We agreed that they are everywhere. We are talking through computer. What is minimum requirement for working of a computer? Anybody?
Processor, sir.
Okay. One answer is processor. I can also see the chat box. Yes, Mihir, you're right. It's a processor.
Input output devices.
Very good, fantastic. Software and hardware, very good. Last 10 seconds, if anybody wants to add. Okay, motherboard and the motherboard CPU.
Power supply.
Okay, power supply. Anyway, good answers, very nice. I'm happy that you are interacting and you are answering. Okay, let's go ahead. Let's answer it. What is minimum requirement for working of a computer? Your concentration is required. I'm going to bring one very important concept in our discussion. Discussion for about 5 minutes. Let's move. Computer is an electronic machine which processes the data. Question is, from where my data will come? How data will come inside the computer? For that, we need some hardware devices called input devices, like a keyboard. And through keyboard or input unit, we get data into the computer. We read data into the computer. This is one minimum requirement. Okay. So I know how to enter the data into the computer. It is called input unit. Computer is an electronic machine which processes the data. I'm not deviating from my definition. I know how to get the data. How I will see the data? How I will verify my result, my data is correct? For that, we need hardware devices called output devices or output unit, like monitor. What you are observing is from the monitor. You can see me, you can see my PPT, the animations which are coming on that PPT. So we display data using output devices or output unit. Okay. Normally, this is called IO devices. I for input and O for output. Okay. IO is a minimum requirement if we want to work on computer. Computer is an electronic machine which processes the data. I know how to get the data via keyboard. I can see the data via monitor or output device. $1 million question is, if computer is an electronic machine which processes the data, how my computer performs data processing? For that, we need hardware called CPU, or it is called microprocessor. That is our subject. central processing unit, or it is also called microprocessor, is a hardware which processes the data. You can compare the data, you can add the data, you can subtract the data. So many processing you can do. Who does it? CPU. More precise, microprocessor, our subject title. So we have brought our subject. Now we are going to explore in next 10 or 12 sessions what is the magic of microprocessor, what's there inside. I remember, just a change of topic for 2 minutes, I have read one statement scrolling on manufacturer of a microprocessor. You know, Intel, ARM, they are all manufacturers of microprocessor, or maybe Qualcomm. The line was, or statement was, microprocessor is a toughest thing designed so far on the earth, and you will experience it as we go ahead. Okay, coming to our computer, who processes the data? It's a CPU or microprocessor which processes the data. I know how to read the data, I know how to process the data, I know how to display the data. Minimum requirement of a computer. You can see how your subject is important. How I will remember my data? That is my next question. How I will see my data after 2 hours, maybe 2 days, maybe 2 years? For that, we need one more hardware called memory. That hardware is used to store the data. Be very alert. When I use a word memory, I am referring to one memory called RAM, that is random access memory. Okay. In COA, you have studied memory organization, you have studied memory hierarchy, and you are aware there are different memories in the computer, starting from cache memory, main memory, disk memory. So what I'm referring is main memory, or it is called RAM, random access memory. Okay. So my data will be read, my data will be processed, my data will be displayed, my data will be stored. This is my computer. Okay, minimum requirement for my computer. Can you tell me what is missing in this particular diagram? Anybody? Very good.
Storage.
Storage, I referred memory, so storage is there. Type, we are not concerned here. Memory, we referred. So storage, we have shown. What Karan is sharing is perfectly correct. That is connections. Okay. Be alert. We are bringing one concept and we are going to explore it for our 8086 microprocessor. Question is, if I read data, how I will give my data for processing? if I process my data, how I will store data in the memory, or how I will display on output device. There is a gap, and that gap we have to breach. Why there is a gap? There is a gap because how my data will travel from input device to the processor, from processor to the output device, from processor to memory like RAM. That we do using a system called bus. Okay. Now, why it is called as a bus? Because just like a human being, if we are in Mumbai, we use BEST to travel from one place to other, the most common public transport after railways. If we are in Thane, we use TMC. If we are in Kalyan or Dombivli, we use KDMC. So transportation for human is a bus. Like that, inside a computer for transportation of data, we use bus. What is a bus? Bus are metallic conducting path or wires used to transfer data from one block to other block. Like if my data is coming from keyboard and if I want to give it to the processor, I need bus. If I want to share data from processor to memory, I need bus. So it's a transport medium. Okay, let's bring those buses. Now you can see my computer is functionally complete, and now we have interconnection called bus. It's not a decoration, that is called as bus. Okay. Now let's go one step. What are the types of buses? Because now we understood that buses is one of the minimum requirement. When we talk computer, when we talk microprocessor, IO, memory, we need bus. I defined what is a bus. There are three types of buses. And these buses, from input device, what you read, it will be shared with the processor, maybe for addition or comparison through bus. You can see what you see is a binary data. You know, different conversions, 1/5 decimal. If you convert in binary, you get 1111, and that is what we share on the bus, because your computer is a digital device. It works with the bits. That all communication we do via bus. There are three buses. One is called address bus. It is called AB in short form. Second one is called control bus. Short form is CB. And third is called data bus. Short form is DB. So basically we have ABCD. A for address, B for bus, C for control, B for bus, D for data, B for bus. These are three buses which are always required in computer, typically microprocessor, because our focus is here. I said we are going to explore this because that's the very critical block. And finally, combination of these three buses, address bus, control bus, and data bus, Together, it's called system bus. We abbreviate as SB. So what is the system bus? It's a combination of address bus, control bus, and data bus. So what you see in the diagram, this one is a system bus, because otherwise you have to show 3 arrows everywhere: address bus, control bus, data bus. And wiring will be more and your blocks will be less. So normally what we show is a single bus called system bus. It's a combination of all 3: address, control, and data. We discussed about computer, functional blocks of the computer. We brought microprocessor, and we started discussion of buses, types of buses. So we discussed for about, let me check. Yes, for about 38 minutes from the start. It's your time. If you have any questions, then definitely I will be happy to answer your questions. So my question to everybody is, any questions? Check if you require any clarification. Otherwise, we will bring these points in notebook. I hope you are ready with the notebook, and I will give some points. Of course, rest all you will get through our other notes. We will follow blended approach because we have to manage time also. So check it out. I can see some responses that there are no questions. That's great. No news is a good news. Okay, there is a question from here. ROM is not mentioned. Is it because it stores less memory? Okay, Mir, that's a good question. I will answer it in single line because many details will be coming. The memory which normally processor refers, it's called as RAM. That is the reason ROM is not mentioned, and what I have mentioned is RAM. Whenever I use a word memory, I'm always referring to RAM. Okay, those reasons, like I said, will be coming. Okay, any other question? I'm really happy that you are a little curious from these questions, that why, how. That's great. Okay, I think there are no questions. If you are ready to write, please type YES. So I will come to know, I will start my dictation. Okay, Aditya, thank you. Thank you, Om. And now we are writing. Okay, okay, Samiksha, that's great. We are writing. Currently, I'm not teaching, I'm dictating. Okay, take out your notebook. Part 1, title is Functional Blocks of a Computer. Title is Functional Blocks of a Computer. Just 1 minute before I start dictation. All these slides also I will be sharing. Okay, so you will get all these slides also. I will convert this into PDF, and then we will share it through our app. Okay, where you will find notes. In that you will find our weekly PDF of our discussions. Okay, so this diagram and all that you can refer directly from the slide. Only points, important statement I will give you. Okay, so we will have a better time management. So every week I will be sharing this PDF, whatever we are learning. Okay, just one instruction. I think I must share it. Okay, now I'm dictating. Let's go back. Functional blocks of a computer. That is the title. Now write down points 1, 2, 3, 4 that way. Point 1. Computer is an electronic machine. Computer is an electronic machine which processes the data. Computer is an electronic machine which processes the data very fast, such that every computer has some minimum requirement. I repeat, computer is an electronic machine which processes the data very fast, such that every computer has some minimum requirement. Go to second point. Point number 2. Such that every computer has some minimum requirement. Okay. Point number 2. Every computer, this is point number 2, requires hardware. Every computer requires hardware to read the data, comma, display the data, comma, process the data, and store the data. I repeat, every computer needs hardware to read the data, comma, process the data, comma, display the data, and store the data. Point number 3.
So diagram पे दिखा.
Yeah, diagram will come, but that diagram you can draw after I share this PDF. Okay, so what I suggest is that you write all these points, keep some space, and in that space you can draw diagram later once I share this PDF. You got my point?
Yes, sir.
Yeah, so that we can save some time. Okay, because every week I will be sharing, maybe in 1 or 2 days I will share, and you will able to access. They will tell you how to access and all that. Okay, can we proceed, or any other queries there?
No, sir.
Yeah, okay, let's move on. So point number 3, we are writing data is read, or displayed, data is read or displayed using IO devices. Data is read or displayed using IO devices. IO means input output, comma, it is processed using microprocessor. It is processed means data is processed. It is processed using microprocessor or CPU, and it is stored using memory like RAM, and it is stored using memory like RAM. Okay, we go to 4th point. I hope my dictation speed is okay. Point number 4. Very important, we are going to talk about bus. All these hardware devices, all these hardware devices, all these hardware devices are interconnected. All these hardware devices are interconnected using bus. All these hardware devices are interconnected using bus. Now we are defining bus, okay, in the same point. So write carefully. Bus is defined as group of group of metallic conducting path. Bus is defined as group of metallic conducting path or wires used to transport data from one functional block to other. I repeat again, bus is defined as group of metallic conducting path or wires used to transport data from one functional block to other. Definition is done. Now go to last point. Our initial points are complete. I think point number 5. There are 3 basic types of buses. There are 3 basic types of buses. It's a plural, called address bus, comma, control bus, and data bus. There are 3 basic types of buses called address bus, control bus, and data bus used inside a computer, such that combination of these 3 buses it's called system bus. Combination of these 3 buses, it's called system bus. Okay, my dictation is complete, and now we are good to move one step. Okay, if all is good and if you are ready, then please type again YES in the chat box. Let me see how many of you are ready to go ahead. My points are complete. Okay, that's great. I can see lots of responses, and go on interacting with me. Okay, try to give all answers whatever way you can. Okay, let's go on. Now I'm not dictating, I'm teaching. Okay, slightly the matter will become now more and more complex, okay, as we move. We understood what is a computer. We understood where is microprocessor, why we are studying this subject. It's a processing element. It's a person who does. everything in computer. We understood what is a bus and what are basic types of buses. I know many questions are coming in your mind. What is address bus? What it does? What is control bus? What it does? That we will try to understand in our next discussion. Okay, so concentrate. For that, let's have some observations. One observation is that you will find one microprocessor is visible on my PPT. This is 8086 microprocessor, what you see. We will be studying it. And many pins of this microprocessor, I hope diagram is clearly visible. I have taken care, are address bus, control bus, and data bus. So it is not like we are only studying, we are physically using. So many pins of this microprocessor are address bus, control bus, and data bus. You will see, because we are entering 8086 progressively. This is one observation. Buses are important. That is one point. If there is no bus, there is no transport. It is so simple. And all these devices will be handicapped. Second observation is one question. My question is, if you are good listeners, you must have identified when I discussed about my computer, I have used one word frequently when I talked input unit, when I talked output unit, when I talked microprocessor, introductory, when I talked memory. One word I have used frequently. Can you tell me which word I have used frequently? Anybody? Process, okay. Data, okay. Very good. Data is one answer, I agree. Microprocessor, okay. Still I'm searching for that word, because bus, okay, that is also correct. All these words I have used frequently, but still something is missing that I am searching. All answers are correct, I agree.
Input output.
That is what I use.
Yes, input output, agreed. Still system, okay, I used sometimes. Electronic machine, okay. Okay, let's go on, because it's a riddle and probably what I'm searching is still I have not received. Okay, be alert. I said hardware device to read the data, hardware device which process the data, hardware device which display the data, hardware device which stores the data. So the word that I was looking from you, expecting from you, was hardware device. Okay. Now why? Answer is, all these components of computer are hardware devices. Okay, I hope you know what is a hardware. I will not go into that. My question is, can my hardware will work directly? What is your answer? All these devices are hardware devices. Your microprocessor is a hardware. So my question, can my hardware will work directly? Is it like I purchase microprocessor, I put in my computer and it will work? Let me see what is your thought. Okay, Mir is telling no. Yeah, agree. Any other answers?
It needs some input.
Okay, it needs some input. That is okay, agreed. Yes. I think the word which I was expecting, now I can see. I think Aditya has given that answer. The answer is correct. Let me share with everybody. The answer is no. I will prove in next 7 to 10 minutes what I'm talking. My hardware will not work directly. I need software to run hardware. I repeat, my hardware will not work directly. My computing hardware will not work directly. Please be alert. I need software to run hardware. So the next question is, how to get that software? What is your answer? Okay, Sumit is telling OS. OS, okay. Aditya is also telling OS because you are studying as a parallel subject. Okay. Looks interesting. Any other answers? How you will get software? See, you are coming from programming background. So I was expecting some prompt answers. The only one way to get software is program. So if you want to get any software, you have to write a program. Understand? When I teach programming subject, I always use one statement. It's a simple mathematics. LHS is a software equal to RHS, right hand side, is a program. So every software is a program. Either you make it or you get it. These are the only two options. Okay. So the point is, my hardware will not work directly. I need software to run hardware. And to get that software, I have to write a program. And what is a program? Let me answer it. Program are the instructions to perform some task. Okay. Now be very alert because I'm going to map this with our computer. Okay. Very alert because I need it at many places in my next level of teaching. So I hope this link is very clear. All my computing devices are hardware devices, including microprocessor. Can my hardware will work directly? No. I need software to run hardware. How to get software? Through program. Every software is a program. One answer some people have given is OS. I don't know how much study you have done for OS. It is start of semester 4. But any OS is a very complex program with billion lines of code. So out of curiosity, you try to find out what is the size of the code, number of lines for a particular operating system. You will be surprised. Okay. Point is, I need program. That's why there is an assembly language programming in this subject. Okay. We are far away, but I'm just mapping. Now, let me link it. I said my processor, microprocessor, is a hardware which processes the data. Am I correct? Question is, how my processor processes the data. It's a question to a question. Who processes the data? Microprocessor. That is our subject. Fine. But how microprocessor processes the data? What is the intelligence? That answer is software or a program. My microprocessor processes the data through program. Understand? I repeat, my processor processes the data through program. My processor executes program, and through execution of program, your data will be processed. So the entire life of microprocessor is to run the program, nothing else. And where we store that program in memory called RAM. Understand? That's why I've said whenever I use a word memory, the default memory is RAM. It is also called main memory. मतलब क्या? Just a change of language. आपका माइक्रोप्रोसेसर हमेशा प्रोग्राम एग्जीक्यूट करेगा एंड थ्रू दैट प्रोसेसिंग करेगा. दिस इज नंबर 1. एंड आपका जो प्रोग्राम है जो एग्जीक्यूट होता है, दैट वी स्टोर इन मेमोरी कॉल्ड रैम, नॉट इन रोम, not in hard disk, not in pen drive. That's why the memory that I'm referring is RAM. प्रोसेसर को सिर्फ एक मेमोरी पता है, RAM. Okay. Let me give last example, then I will go ahead. Okay. Now you are aware what is a microprocessor and what we are going to see into that. You have studied C programming. I think Java also you have studied in previous semester, maybe skill laboratory. How you read the data using keyboard. But for that, you need instruction called scanf. So scanf is a part of software and keyboard is a hardware device. That's why I've said hardware needs software for execution, for working. So through scanf, you are telling keyboard, you are reading data through keyboard. Through printf, you will be displaying on monitor. Okay. Now, let's go ahead. Our observations are complete and our fundamental is now ready. Okay. We talked about maybe 1 hour and now we are absolutely ready for microprocessor. We know what is microprocessor. Okay, now let's slightly explore these buses. Okay, your concentration is required because this is a conceptual part and this we may not write, not important for exam because your exams are written, but conceptually we are discussing. Okay. I said there are 3 buses: address, control, and data. Now let's understand why we need 3 buses. Okay, next 20 minutes, I'm going to bring 8086 microprocessor. Okay. I want to ask 2 questions. Let me see how much you are listening to me carefully. Question 1. What you see on PPT is a computer. Can you tell me, in my computer, who executes the program?
Microprocessor.
Very good. Fantastic. It's a microprocessor who executes the program. Okay, because when I ask this question during oral practical exam, I get answers like compiler, interpreter. They don't execute the program. They are translators. Understand? They will convert high level program into machine language. Execution is done by microprocessor. So that answer is correct. My second question, where you store the program for execution?
RAM.
Exactly. The memory where you store the program is RAM. Okay. Processor refers to RAM. Processor do not refer to hard disk, pen drive, ROM. जब भी प्रोसेसर को प्रोग्राम एग्जीक्यूट करना है तो वो रैम में जाएगा देखने के लिए कैसे अभी मैं पढ़ाता हूं. ओके फाइन. Okay, now time to move and for you time to focus. Now what we will do, हम लोग थोड़ा वो रैम को एक्सप्लोर करेंगे, थोड़ा अंदर जाके देखेंगे, तभी पता चलेगा एड्रेस बस, कंट्रोल बस और डेटा बस, what is the meaning and what they do. Okay, because this we need for our microprocessor. Okay, let's go into memory called RAM. Okay, so I'm going after observations. Okay, focus. Let us assume that this block represents a memory called RAM. Okay, random access memory. And let us assume we have a program with some instructions. You can see I1, I2, I3, I4, I50. Okay, I stands for instruction. Instruction 1, instruction 2, instruction 3, instruction 4, like that. We are not concerned whether that program is C program, Java program. We are absolute general. Okay, fine. If you look into memory like RAM, this RAM has billions of locations one after the other. You can see there are some rows which are in red color. Clearly they are visible. You can see this is row 1, row 2, row 3, row 4, like that it is going. So inside RAM we have billions of locations and every location is called memory cell. Observe it. So this is one memory cell. This is another memory cell. This is another memory cell. And like that it is replicated. Typically, every memory cell, or I will use a word location because that is simple. Every memory cell or location can store 8 bits. You know, group of 8 bits. It's called byte. Those 8 bits are called D0 to D7. Observe it. This is D0 and this is D7. Total number of bits are 8. D1, D2, D3, D4, D5, D6, D7, like that. D0 to D7. And same is repeated. So next location will store another 8 bit or a byte. Next location will store another 8 bit or byte, and like that. Okay. And every location or every memory cell has address. Observe it. Can you see that the start address is 00000. This H stands for hexadecimal. In digital logic, you have studied number systems, and in that you know hexadecimal number system. H stands for hexadecimal. I hope you know what is hexadecimal. So this is 0001, like that. This is some random location, let us say 1000. This is some random location, let us say 2000, like that. This sequential. Now be very alert because I am going to bring buses. Okay, and that discussion will be complete. Address bus, data bus, and control bus. Okay, so focus. Okay, there is something in chat box. You have a look little later. Fine. I repeat again so that everybody is on the track. Stick to the machines, mobile or laptops, listening to me carefully. This is a memory called RAM. We are only considering block diagram. Memory like RAM has billions of locations called memory cell. Every location can store 8 bits or a byte, D7 to D0, and it is replicated everywhere. It is a byte stored. Every location has an address starting from 0, 1, 2, like that. I have shown some random addresses in hexadecimal. We always use hexadecimal system for memory address. Always remember, we never talk decimal. We never talk binary. We talk hexadecimal in address. D7 is normally called MSB and D0 is normally called LSB. Can you tell me what is MSB and LSB quickly?
Most significant bit, least significant bit.
Yes, perfect. Now let's bring our buses and complete this discussion. You will never forget why we need buses. Okay, अभी अच्छे से सुनना है what I'm talking. Perfect answer, Mir. You're right. And those who have answered MSB, LSB, most significant bit, least significant bit, that is correct. थोड़ा बीच में मैं लैंग्वेज भी चेंज करूंगा, तो थोड़ा कैसे है कि वी अंडरस्टैंड बेटर. ये मेरा प्रोग्राम है. दिस इज माय प्रोग्राम. दिस प्रोग्राम कैन बी ए सी प्रोग्राम और जावा प्रोग्राम और C++ प्रोग्राम or Python program, whatever. If it is a C program, I will use compiler to convert my high level program into machine language. I hope that much details you have studied in your previous semester. Okay, मतलब 0101 में मेरा program convert होगा when I compile. And that program I store in the memory. Okay, like 1 byte, 2nd byte, 3rd byte, 4th byte. That way I store in memory like RAM. Okay. Where is my program? It's in memory. And who executes your program? Microprocessor or CPU. Okay. सबसे बड़ा क्वेश्चन ये है, the very fundamental question is how processor will understand in memory like RAM where is my program, because there are billions of locations. I said today we are talking RAM in GB, gigabytes. Gigabyte का मतलब है 10 raised to power 9. That means billion. There are such billions of locations. So how processor will come to know in RAM in which location, observe this carefully, in which location my program starts. For that we need address bus. Address bus tells where to go in memory, where is a program stored in memory, because it carries address. See, this information you communicate through address bus, because what is a bus? Group of lines, metallic conducting path, wires to transport the data. Now what I'm transporting? Address. my program starts from 10000. This I will transfer on address bus. Or 20000. This I will transfer via address bus. Bus matlab many lines, group of lines, group of metallic conducting path. Don't forget. Okay. So address bus will tell where to go in the memory. तो प्रोसेसर को पता कैसे चलेगा कि इतने सारे लोकेशंस अगर मेमोरी में है, जाना कहां पे है, मेरा प्रोग्राम कहां पे है, दैट वी टेल वाया एड्रेस बस. इसके लिए एड्रेस बस बहुत इंपॉर्टेंट है. ओके, लेट अस अज्यूम थ्रू एड्रेस बस we tell processor program starts from 10000. This we put on address bus. वो कैसे होता है सब कुछ मैं पढ़ाऊंगा. उसके लिए अभी आर्किटेक्चर की तरफ हम लोग जा रहे हैं. 86. ओके, तो फॉर सिंप्लिसिटी ये समझने के लिए लेट अस अज्यूम थ्रू एड्रेस बस we tell processor that program is at 10000H. ओके, तो प्रोसेसर विल कम टू नो, हाँ यहां पे प्रोग्राम चालू हो रहा है. ठीक है. Who executes the program? Processor. Where you store the program? In RAM. Okay. Next step is that once processor knows at this point my program is there, प्रोसेसर को कैसे पता चलेगा कि मुझे ये लोकेशन है 1000, वो रीड करना है कि राइट करना है? बिकॉज यू कैन परफॉर्म ओनली 2 ऑपरेशंस ऑन मेमोरी. मेमोरी इज अ बुलियन डिवाइस. आई नो you have studied digital logic fundamentals, and boolean means only 2 possibilities, true or false, yes or no. So memory में सिर्फ 2 operations होते हैं, one is read and second one is write. okay, तो प्रोसेसर को कैसे पता चलेगा कि ये जो लोकेशन है वहां पे मुझे रीड करना है कि वहां पे मुझे राइट करना है? फॉर दैट वी नीड कंट्रोल बस. So through control bus we tell read, और through control bus we tell write. इसके लिए उसका नाम है कंट्रोल. सी, कंट्रोल मतलब what you want to do, ऑपरेशन क्या करना है. ओके, सो one is address bus, second one is a control bus. Fine. अभी लास्ट का जो बस है वो है डेटा बस. Let's take same example, okay, and to conclude this discussion. Through address bus, processor will understand at 10000 program is available yahan pe. So this information will go on address bus. Through control bus, processor will understand I have to read. मुझे instruction read करना है memory से. Okay. So you will read one instruction like I1. ये instruction आप read करोगे. अभी जो instruction आप read करोगे, whatever instruction you will read, you have to bring it inside the processor. वो instruction आप transfer कैसे करोगे जो आप read कर रहे हो? For that we need data bus. So data bus carries actual data or actual instruction you are reading, and all these 3 buses works together. Like I said, it is called system bus, क्योंकि सिर्फ एड्रेस बस होने से आपका काम नहीं होगा, सिर्फ कंट्रोल बस होने से आपका काम नहीं होगा, सिर्फ डेटा बस होने से आपका काम नहीं होगा. तीनों बसेस साथ में होना चाहिए. इट्स लाइक अ सिंपल ह्यूमन बॉडी. देयर आर ऑल वाइटल ऑर्गन्स inside a human body. We have heart, we have lung, we have brain, and they are working together. ऐसा नहीं है कि एक काम कर रहा है और दूसरा रेस्ट कर रहा है, ऐसा नहीं है. They are working together. Like that, these 3 buses work together. One bus tells where to go in the memory, address bus. One bus tells what you want to do. You want to read or you want to write? Control bus. And what you read, what you want to write, that actual data, actual instruction you carry through data bus. And that combination is called system bus. That completes our discussion of basic fundamental buses. Check if you have any specific queries. I'm ready to take your questions. Check it out if you have any specific queries. I think we are discussing for close to 1 hour and 30 minutes, little less. Now we are moving towards further discussion. Okay, any queries? I'm waiting for your questions. Okay, अभी ये जो पार्ट है वो एक कंसेप्चुअल पार्ट था जो मैं डिस्कस कर रहा था फॉर अबाउट लास्ट 20 मिनट्स. तो इसको हम लोग नहीं लिखेंगे, ये सब पीडीएफ में कन्वर्ट करके मैं डायरेक्ट आपको शेयर करूंगा. As of now, we will go one step ahead. Okay, we are going into 8086 microprocessor. So if you are ready, type YES. I will come to know we can move. Okay, great. Now this I will continue. Okay, इसको ही आगे लिंक हम लोग करेंगे. So focus. We are going ahead. Now this hardware is your 8086 microprocessor. Okay, look is important because look matters. So this is how your 8086 microprocessor looks. It's one of the old microprocessor, but old is gold, and definitely this is gold because all your modern microprocessors, they are coming from this gold, that is 8086. Now let's use all these concepts to talk 8086 microprocessor. Okay, because you know what is a bus, you know why we need address bus, you know why we need control bus, you need data bus. Okay, let's start with the features of 8086 microprocessor. Okay, we are entering in 8086. Possible question in our last 1.5 hours of discussion. One question: what is a bus and what are basic types of buses? This is the most common possible question that I have already given some dictation. Diagram you will be getting through PDF. Okay. x86 microprocessor is having 16-bit data bus. Observe it now carefully. These words now you will understand. That's why I have spent some time to make you better. Okay, so how many data lines are there? 16 data lines are there, or data bus is there. It is D0 to D15. D15 is MSB, D0 is LSB, and it has 20-bit address bus. Very important for your IA1 type of exam because they are normally objective, and you can get select the correct option and you can get different permutations and combinations. Like 8086 microprocessor has 20-bit data bus, 16-bit address bus, 16-bit data bus, 20-bit address bus. So you should be able to identify. Okay. More we will talk. We are only collecting features. This microprocessor supports maximum 1 MB of RAM. 1 MB stands for 1 megabyte. Okay. Why? That also we will talk. This is a processor with 40-pin IC. I think in the previous slide, I have shown you a simple look. And If you see this microprocessor, you will find that this is pin number 1, because normal convention is that this is called horseshoe notch. That is a technical term. And from this notch, we go in anti-clockwise direction. So number the pin. So this is pin number 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these are 20 pins, and on other side there are 20 pins. So it's basically a 20 plus 20, 40 pin IC. It's a complete hardware. This processor works with 3 clock frequencies: 5 megahertz, 8 megahertz, 10 megahertz. Very important for I1 examination, because these small questions normally they ask to check how much you know about fundamentals of a processor. So how many clock frequencies are there? 5 megahertz, 8 megahertz, 10 megahertz. Okay, these are 3 clock frequencies. You will understand why we need clock and all that. We are going into 8086. This processor uses pipelined architecture. Okay, it is coming in my next discussion. This processor uses one technique called memory segmentation. We'll be talking in architecture. It also uses a technique called memory banking. This also we will be talking in architecture. Okay, around 3 sessions we are going to talk about architecture, because the maximum weightage is for this particular module 1, and one more module is there where there is maximum hours are specified, because normal thought is that number of hours are more, the weightage is more, that way. So we will be talking. And you can program this processor using assembly language programming or assembly language instructions. Okay, so this we will not write, because 3-4 times I said that this I will convert in PDF, and I will give you all these details. You can directly start studying from that PDF. Okay, I will convert this PPT in PDF and you will get it on weekly basis. Fine. Now we will go into 8086 microprocessor. Let's start with one question. Can you tell me what is a pipelined architecture? Anybody? What is a pipelined architecture? You can unmute and answer, or you can use chat box. You have studied COA, don't forget. Is it so difficult? What is pipelined architecture? Okay. Let me answer it. No problem. That's okay. Karan is telling to improve performance of a computer. Yes, Karan, you are right. But I'm sorry. This is the marketing answer, you know. This is good if you are talking like a salesperson. If you're talking to an engineer, then may not be a good answer. But yes, can be a acceptable, improve the performance of a computer. Great. Any other answers? Manish is telling pipelining is a technique where multiple instructions are overlapped during execution. Fantastic, Manish, you are right. Bilal is telling process of fetching. Yes, very nice. When present instruction is being executed. Yes, that is more technical. Great, Bilal. Okay, now let's go ahead with this. मुझे अभी पहले का जो मैंने सिखाया ना उसका रेफरेंस लगेगा, तो आपको बहुत अलर्ट रहना है। मैं कुछ क्वेश्चंस पूछूंगा और थ्रू दैट वी आर गोइंग अहेड विथ पाइपलाइन्ड आर्किटेक्चर of 86. Okay, let's make it very interesting through question answers. I'm going one step. You're familiar with this word, okay? What you see, the title of my PPT, that is a gentleman, von Neumann model. Anyway, I'm not teaching von Neumann because that I have taught in COA. You have studied in COA, DLCOA, but now I want to refer it. Focus point of discussion is around 20 minutes further. From our last 1.5 hours of discussion, everybody will agree that program is always executed by microprocessor. Okay, now there is no confusion. The entire life of microprocessor is to run the program. If there is no program, your processor will go in dustbin. It is so simple. Okay, the program that you are executing is in memory called main memory or RAM. Okay, fine. And observation is that person who can execute the program cannot store the program, and person who can store the program cannot execute the program. Okay, then question is how my processor will execute the program, क्योंकि program तो RAM में है और execute करने वाला processor है, तो कैसे होगा? For that we use von Neumann model. What is that? Just the summary, because we want in processor. Very simple answer is von Neumann model. You fetch the instruction, you decode instruction, you execute the instruction. Fetch, decode, execute. These three magic words forms von Neumann model. Let me map this where we started. Okay, this is our long journey of today's session. Good journey, informative journey. Okay, here we are. See, here is my program. Processor executes my program. Processor will go to memory like RAM. Through address bus, it will find where is the program. Through control bus, it will read instruction of that program. I hope you are able to map. And through data bus, that instruction is brought into the processor. That is called fetch, FETCH. आपका प्रोग्राम यहां पे है, आपका प्रोग्राम यहां पे एग्जीक्यूट होता है. सो देयर इज अ गैप. गैप मतलब नॉट ट्रांसपोर्टेशन, उसके लिए बस है. पर्सन who stores cannot execute, person who execute cannot store, that way. So my processor through address bus will identify in what location program starts. I1, I2, I3, I4, like that. Instruction 1, instruction 2, that way. Through control bus read, it will read instruction, and through data bus, it will bring instruction 1 that is called fetch. Okay. Second step, after you fetch instruction, प्रोसेसर को कैसे पता चलेगा ये इंस्ट्रक्शन क्या है? Because what you fetch is instruction I1. See here, what you fetch is instruction I1. Okay, I1, I2, I3. अभी प्रोसेसर को कैसे पता चलेगा ये इंस्ट्रक्शन I1 ऐड इंस्ट्रक्शन है, सब्ट्रैक्ट इंस्ट्रक्शन है, मल्टीप्लाई इंस्ट्रक्शन है, डिवाइड इंस्ट्रक्शन है? फॉर दैट we decode the instruction. Decode means find out what is that instruction. Is I1 is add, is I1 is subtract, is I1 is MUL, is I1 is DIV? That is called decode. And once you understand, okay, my instruction is add, you actually perform addition. That is called execute. My point is, if I go where we were discussing, okay, again long journey here and we reach finally. Okay, here we were talking. So how my program is executed? My program is executed using fetch, decode, execute. Okay, and how it looks, let's see. And we bring 86 pipelined architecture. Let us assume that my program has many instructions, I1, I2, I3, like that. So what we can do, my processor will fetch instruction 1. It will decode and execute instruction 1. You can see F stands for fetch, E stands for decode and execute. Okay, just for simplicity, I have put it as a single block. You can see very clearly. Execute means decode and execute. Okay, so fetch instruction 1, decode and execute instruction 1, fetch instruction 2, decode execute instruction 2, fetch instruction 3, decode execute instruction 3, fetch instruction 4, decode and execute instruction 4. I will take only 4 instructions, okay, for our example up to this. And that way your program will be executed. So every instruction you will do fetch, decode, execute, and you apply for sequential consecutive instructions. This architecture is called non-pipelined architecture. See carefully. Okay, this was used in old processor called 8085. 8086 is what you are learning. Before that, there is a processor 8085. They are all Intel processors. In that, this approach is used, that is non-pipelined architecture. Now, my question is coming just to see how much carefully you are listening, because today mainly we are discussing concepts. My question is, can you tell me what is a problem of non-pipelined architecture? Anybody? Any cases? This architecture is never used further after 8085. Okay, let me see the answer.
Without pipeline, you cannot fetch, decode, and execute instructions.
No, we can fetch, decode, and execute because we are doing one by one. Yes, that is one answer I can see. Some more inputs. Last 10 seconds if anybody wants to add. Okay, here we go. Problem is that non-pipelined architecture is a complete sequential process. And because it is sequential, it will take more time. So the time to execute program will be more. If there are more instructions, you will require more time. Because if you see carefully, this is a time axis. Observe it. Okay, and these are the times that I'm talking. See, okay, so in time t1 you will fetch, in t2 you will decode execute, then t3 you will fetch second instruction. Like that, time required to run the program will be more. Direct impact, because anything sequential takes more time. Simple. And that is a reason pipelined architecture was designed. So your answer was correct. Somebody has answered pipelined architecture improve the performance. And the technical reasoning is now visible here. Now let's see what is a pipelined architecture. Observe it. So what is a pipelined architecture? We design a processor such that we fetch instruction 1. Okay, how we fetch? Using system bus. Through address bus, we identify what is the location instruction is available. Through control bus, we read, and through data bus, we actually bring that instruction into the processor. We need buses. See, what is a fundamental requirement? If there is no bus, forget about fetch, decode, execute. So you fetch instruction 1. Now be very alert. When you are executing, decoding, and executing instruction 1, at the same time you fetch instruction 2. Observe carefully. So now what is the change in architecture? You are not sequential. You are adding some concurrency, some parallel approach in your architecture. This is a sequential architecture. But now in your architecture of the processor, in the design of the processor, you are adding some concurrency. What is that? When you are decoding and executing instruction 1, you are fetching instruction 2. When you will decode and execute instruction 2, you will fetch instruction 3. When you will decode and execute instruction 3, you will fetch instruction 4, and then you will decode, execute instruction 4. Very clearly, you can see time required to execute 4 instruction is T8 in non-pipelined architecture, and time required to execute 4 instruction is T5 in pipelined architecture. That is a reason every processor from 8086 use pipelined architecture. Question is, what is pipelined architecture? Let me define. It's the architecture of a processor where there is overlap between instruction fetch and instruction execute. You can say decode execute. There is an overlap of instruction fetch and instruction decode execute. At the same time, you are fetching next instruction and you are decoding, executing previous instruction. This overlapping is called pipelined architecture. There is also reason how that word pipelined is coined. That also we will see. And if you see carefully, during T1, T2, if you take this particular span, okay, if I project it, and if you take T1, T2 as a span, then I'm using two important tasks. One is fetching of the instruction, and second one is decode and execution of the instruction. This type of architecture is called two-stage pipelined architecture. Your 8086 microprocessor is a two-stage pipelined architecture. One stage to fetch and other stage to decode execute. It is called two-stage pipelined architecture. Check if you have any specific queries. This we will bring in our notebook. Check it out. I'm ready to answer your questions. Let me raise a question. And my question is, any questions? Please check. If you have any questions, I'm ready to answer. We are working for about close to 2 hours, little less. Come on, I'm ready to answer your questions. And if you have no questions, then you can tell me in chat box. No questions. Excellent, Yogesh. I'm happy that you're putting it positive comment, and that's why I'm here. Okay, I think we can go ahead. If you are ready for writing, type YES in chat box. It will tell me you are ready, I'm audible, I'm visible, and you are listening to me. And I want responses from everybody. I will see a chat box. Okay, okay. Okay, back to notebook. I'm dictating now for about 10 minutes. Okay, I'm not teaching right now. मैंने आपको ये बताया कि फीचर्स ऑफ 8086 माइक्रोप्रोसेसर हम लोग नहीं लिखेंगे, क्योंकि ये मैं डायरेक्ट शेयर करूंगा आपके साथ. उसमें सब कुछ है, पीडीएफ में आप गो थ्रू करो. उसके बाद अभी हम लोग डायरेक्ट जाएंगे पाइपलाइन कंसेप्ट की तरफ. ओके, सो गिव द टाइटल. टाइटल इज कंसेप्ट ऑफ pipelined architecture. This is the title. Concept of pipelined architecture. This is the title. Again, points will come. I'm dictating, be alert. Concept of pipelined architecture. Okay. Point number 1. .8086 microprocessor 8086 microprocessor use a two-stage pipelined architecture. It's on PPT. 8086 microprocessor use two-stage pipelined architecture to improve the performance. I repeat, 8086 microprocessor use two-stage pipelined architecture to improve the performance and reduce time to execute the program, to improve the performance and reduce time to execute the program. Point number 2, we will define what is pipelined architecture. A technique in which, point number 2, a technique in which there is overlapping of instruction fetch. There is overlapping of instruction fetch, FETCH, and instruction decode and execute. I repeat, a technique in which there is overlapping of instruction fetch and instruction decode execute. It's called pipelined architecture. It's called pipelined architecture. Go to third point. As shown, this diagram, don't draw this. You can draw later once I share PDF. Okay. So we will refer it. Point number 3, as shown in the diagram, using pipelined architecture, time required to execute the program reduces. Time required to execute the program reduces. Time required to execute the program reduces, but complexity of hardware increases. Just add one word, but complexity of processor hardware increases. But complexity of processor hardware increases. Okay. Go to fourth point, last point. In 8086 processor, this is point 4. In 8086 processor, you can write mu p. There are two independent blocks. There are two independent blocks. There are two independent blocks to handle two-stage pipelined architecture. There are two independent blocks to handle two-stage pipelined architecture. Okay. Now listen. Those 4 points are complete. We have brought what is pipelined architecture. Now every session I will give you small homework. One common homework is that whatever diagrams are there that you will draw after I share PDF. Okay. So after these 4 points, you will draw this diagram. Okay. I think I have also dictated 5 points for the functional blocks and bus. There also there is a diagram that you will draw. Okay. That is common homework for every session, all diagrams and all numericals. There are not many, but there are some numericals and there are some design questions, interface. Of course, it will take time, but these are some common homework. मैं आपको बताऊंगा. ठीक है, अभी आगे जाना है. My dictation is complete and now I'm going to start teaching next part. Okay. कुछ questions है तो you can ask before I start. Any questions? Okay. I'm going ahead. Now I'm teaching. I'm not dictating. Okay. One more point I will teach you and you will feel that this is what is engineering. See now. सोचना ये है, ये सब अच्छा है, मतलब pipelined architecture will make your processor faster. Okay. Time to execute the program will be less. Because how you will say that one processor is good than other? One parameter is how much time processor takes to run the program. If it is a less time, processor is good. And that we achieve using pipelined architecture. Question is, here I have written T1, T2, T3, T4, T5, and these are times. I said you fetch instruction 1 in time T1. You decode instruction and execute instruction 1 in time T1, T2. ये times कहां से आएंगे? From where I will get these timings? क्योंकि लिखने के लिए तो अच्छा है, मतलब आपको सिर्फ T1, T2, T3 लिखना है डायग्राम ड्रॉ करते टाइम, लेकिन प्रैक्टिकली ये टाइम कहां से आएगा? For that we need clock frequency. Observe it. When I was talking features of 8086 microprocessor, I said my processor works with 3 clock frequencies: 5 megahertz, 8 megahertz, and 10 megahertz. And everybody has studied BEE, fundamentals of BEE, and everybody will agree time and frequency, they are reciprocal. T equal to 1 upon F, F equal to 1 upon T. So that timing I will get from this clock frequency. That is the reason every microprocessor works with clock frequency. There is hardly any microprocessor which doesn't work with clock. Every microprocessor needs clock frequency, because reciprocal of clock will give me time. Let's take one example. One clock frequency of 8086 microprocessor is 5 megahertz. Is it okay? 1 upon 5 is 0.2. 10 raised to 6 becomes 10 raised to minus 6, because you will write 1 upon 5 into 10 raised to power 6. So it will become 0.2 into 10 raised to power minus 6, that is microseconds. So the time is 0.2 microseconds. So this particular time is 0.2 microseconds. Can you imagine? We are talking microprocessor whose age is more than 40 years. 8086 was invented in 1976, 1977. And during that time, this particular time, T1 is 0.2 microsecond. So this is 0.2 microsecond, 0.2 microsecond, 0.2 microsecond. So it will go like 0.2, 0.4, 0.6, 0.8, and it will go on. Okay. So you will do fetch in 0.2 microsecond. You will decode execute in another 0.2 microsecond. That is decided by clock frequency. Okay. And if you are listening carefully, and if you make your clock frequency from 5 megahertz to 8 megahertz, or 5 megahertz to 10 megahertz, because there are 3 clock frequencies supported by 8086. So if you make 5 megahertz to 10 megahertz, you are well aware, when you increase the clock frequency, when you increase f, your t will decrease, because f and t are reciprocal. So when you increase the clock frequency, your time will decrease, and the direct effect is that this T1, T2, T3, T4 will be more small, or it will reduce. So this T1 will come somewhere here if your clock frequency is 10 megahertz, because it will become 0.1 microsecond. Previously it was 0.2 microsecond. And that is a reason it is normal thought, higher the frequency of your microprocessor, faster is your processor, which is partially true. I'm not saying 100% true, but yes, partially it is true. Higher is the clock frequency, faster will be the processor. Obviously, क्योंकि अगर मेरा 8086 माइक्रोप्रोसेसर 5 मेगाहर्ट्ज पे काम कर रहा है, तो मुझे फेच करने के लिए 0.2 माइक्रोसेकंड लगेंगे, और अगर मेरा 8086 प्रोसेसर 10 मेगाहर्ट्ज पे काम कर रहा है, तो मुझे फेच करने के लिए 0.1 माइक्रोसेकंड लगेंगे. सो नेचुरली प्रोसेसर विथ क्लॉक फ्रीक्वेंसी 10 megahertz will be faster. Okay, so now you are aware why we need clock frequency. थोड़ा आपको ये भी समझना है कि आपका एग्जाम वगैरह वो सब ठीक है, बिकॉज वी आर इन अ सिस्टम एंड वी हैव टू फॉलो. तो आपका एग्जाम क्वेश्चंस वगैरह बहुत सिंपल रहते हैं. दैट इज माय पर्सनल ऑब्जर्वेशन. ऑब्जेक्टिव या फिर जो भी ऑनलाइन में है, या फिर जनरल भी, मतलब व्हेन इट वाज ऑफलाइन, पेपर्स आर वेरी सिंपल. तो getting good marks in exam is very simple when we are discussing all this. But most important is that when you go out as an engineer, when you claim I'm a computer engineer, people will ask you some very fundamental questions. Typically when you are opting for interviews, placements, that can be like this: why we use clock frequency in microprocessor? What is the reason? Or how you will prove that if my processor is working with 10 megahertz, it is faster than other processor working with 5 megahertz? How? So this all you should be able to justify. Okay. Anyway, time to move. Now let's enter the architecture of 8086 microprocessor. Okay, you can see now we are into the architecture of 8086 microprocessor. One important disclaimer: this diagram I have not drawn. This diagram I have directly taken from Intel manual. Understand? Here it is very clearly visible, Intel. Okay, I'm going to use this diagram for teaching. This I have not drawn. The entire reference goes to Intel. Okay. Pay attention. We are going into 8086. सोचना ये है, thought is, we understand 8086 microprocessor is a two-stage pipelined architecture. ठीक है? There is a fetch and there is decode execute. Who will do fetch? The block which performs fetch is called BIU. Observe it. It stands for bus interface unit. Okay, BIU stands for bus, BUS, I for interface, U for unit. You can see there are two logical parts in this architecture. One is called BIU and second is called EU. It stands for execution unit. This performs decode and execute. मतलब 8086 माइक्रोप्रोसेसर का अगर हम लोग ने ब्लॉक डायग्राम देखा, what you see, then this particular block is responsible to perform operation called fetch, and this block is responsible to perform operation called decode and execute. We will see. We are just entering. आज होगा भी नहीं. It requires at least 2 to 3 sessions to take everything, pin configuration and architecture. Okay, तो आज हम लोग BIU के साथ डिस्कस करेंगे. We will be starting with BIU. Okay. Now, if you see, in BIU, there are some blocks. There are 3 blocks. Okay, this is one block, this is a second block, and this is the third block. Let's start with BIU, bus interface unit. You can see here there is a memory interface. Interface का मतलब है connection of processor and memory. Okay, that is called memory interface. और ये जो है वो है bus. This is your bus. Observe it. This is the system bus. क्योंकि ये आपका प्रोसेसर है, ये आपका मेमोरी है और इसके बीच में देयर इज अ बस. ओके, नाउ लिसन केयरफुली. ओके, हम लोग आज इसका डिस्कशन चालू करेंगे एंड देन वी विल गेट इट इन नोटबुक, थोड़ा पार्ट, एंड देन वी विल समराइज. ओके, दिस इज अ प्लान फॉर नेक्स्ट अराउंड 45 मिनट्स. ठीक है, ठीक है. मेरा प्रोग्राम कहां पे है? यहां पे है. Who executes my program? CPU. This entire part is my CPU. जो dotted line आपको दिख रहा है, that is my CPU. 8086. What 8086 CPU does? 8086 CPU, I call microprocessor, will go to memory via bus, of course, system bus, address, data, control. Okay, it will go to memory and it will read instruction from the memory, I1, I2, like that, and that instruction will be brought inside the processor in a facility called queue. Observe it carefully. QUE. I repeat again. My BIU is responsible to fetch instruction, and EU is responsible to decode and execute instruction. Okay, two-stage pipeline. So there are two parts in the architecture, one for fetch, other for decode execute. You can see clearly this partitioning is visible. Okay, what 8086 processor will do, of course, BIU, we are going to start with BIU, bus interface unit. BIU will go to memory via bus, system bus. It will identify where is the instruction through address bus. It will read that instruction through control bus, and it will bring that instruction through data bus inside the processor in a facility called queue. Okay, now let's understand what is this queue for the day. If you see, there are some numbers visible. Okay, that is not a decoration, because normally when 10 marks question comes, explain architecture of 8086 microprocessor, many people don't know what is the meaning of those numbers. Okay, let's understand what is that. The size of this queue is 6 byte. Okay, the size of this queue is 6 byte. What it means, you can bring up to 6 instructions in this queue. Let us assume every instruction is 1 byte. For simplicity, let us assume every instruction is 1 byte. So what BIU can do, BIU will bring instruction 1. Okay, observe it. BIU will bring instruction 1. Okay, यहाँ पे instruction 1 लेके आएगा BIU. Then BIU will bring instruction 2. तो जब भी BIU instruction 2 लेके आएगा तो क्या होगा, ये instruction 1 आगे जाएगा और यहाँ पे instruction 2 आएगा. Then BIU will bring instruction 3. तो उसमें क्या होगा, instruction 1 यहाँ पे आएगा, instruction 2 यहाँ पे आएगा और instruction 3 यहाँ पे आएगा. So this type of queue is a circular queue or it is a moving queue. Okay, जैसे एक instruction आया तो पहले का instruction आगे जाएगा. That is what is the nature of that queue. Okay, let me again explain what I'm talking. Listen very carefully. My BIU will fetch instruction 1. मैं साइड में लिखता हूं यहां पे. Okay, वो instruction position 6 पे होगा. Then my BIU will bring a second instruction. तो instruction 2 यहां पे होगा और instruction 1 आगे जाएगा. My BIU will bring instruction 3. So instruction 2 will go to position 5, instruction 1 will go to position 4, and instruction 3 will go to the top. My BIU will bring instruction 4. So instruction 1 will go to position 3, instruction 2 will go to position 4, instruction 3 will go to position 5, and instruction 4 will come at the top. Okay, like that maximum 6 instructions my BIU can bring into this queue. So it's like a buffer. Buffer मतलब temporary storage. अभी सोचना ये है कि why it is designed, why it is provided. Can you tell me what is your opinion? ऐसे क्यों किया होगा? Why there is a concept called queue? आपको पता है, आपने COA में पढ़ा है, उसका आंसर सिर्फ आपको लिंक करने को आना चाहिए. My question is that why this queue is provided inside 8086? Anybody? What is your thought? क्योंकि ये कॉम्प्लेक्स है, 40 साल पहले की बात कर रहे हैं हम लोग. डोंट फॉरगेट. 1 minute. Let me see the chat box. Okay. नहीं बरोबर है. Isban, what you are telling is right. वो FC FSC है, FIFO है, वो बरोबर है. लेकिन वो प्रोवाइड क्यों किया है, वो मेरा क्वेश्चन है.
Store the instructions in the queue.
ठीक है, इंस्ट्रक्शन स्टोरेज तो एक रीजन है, बट दैट इज वेरी फंडामेंटल रीजन. उसका एडवांटेज क्या है, मतलब व्हाई वी आर स्टोरिंग बेसिकली. नहीं, ओवरफ्लो नहीं है आयुष. योगेश इज टेलिंग स्पेसिफिक टाइम वी नीड इंस्ट्रक्शन टू गो टू एग्जीक्यूट. नहीं, वो भी नहीं है. वो भी आंसर नहीं है योगेश. गुड अटेम्प्ट. एवरीबडी इज ट्राइंग टू गिव द आंसर. गुड. आफ्टर 2 hours and 15 minutes, recommendable that you are answering. Great. थोड़ा सोचो, आपको आंसर पता है. टू शेड्यूल द प्रोसेस. नहीं बिलाल, ये ऑपरेटिंग सिस्टम का कंसेप्ट आप कंफ्यूज कर रहे हो प्रोसेसर के साथ में. शेड्यूलिंग वगैरह ओएस में होता है. ये हम लोग ना जो इंस्ट्रक्शन में बात कर रहा हूं ना बिलाल, वो हाई लेवल की बात नहीं कर रहा हूं. ये मैं मशीन लेवल इंस्ट्रक्शंस की बात कर रहा हूं. मैंने शायद कुछ टाइम पहले बताया कि आपका हाई लेवल प्रोग्राम कंपाइलर या इंटरप्रेटर के थ्रू हम लोग मशीन लैंग्वेज में कन्वर्ट करके मेमोरी में रख रहे हैं. तो ओएस इज नॉट इन पिक्चर नाउ. इंसर्शन एट रियर एंड एंड डिलीशन एट द फ्रंट एंड, वो तो उसका ऑपरेशनल डिटेल्स है प्रथम. दैट इज ऑल्सो पाइपलाइनिंग भी नहीं है इसका आंसर. ओके, लास्ट 10 seconds. आपको पता है, आपने पढ़ा है, बहुत ही सिंपल आंसर है, COA में है उसका आंसर. ये सब पता होना चाहिए व्हेन यू स्टडी. एनीवे, समीक्षा इज टेलिंग दिस वे इट्स फास्टर. थोड़ा आंसर ये है, मतलब क्लोज टू द रियल आंसर. एनीवे, आई विल आंसर इट. फोकस. आज क्यू का डिस्कशन खत्म करेंगे और नोटबुक में भी लेके आएंगे. ओके. सी द आंसर इज to fetch and execute at the same time. That is what Sumit is telling. Yeah. One answer was pipelining. So in line with that, ठीक है, that is priority. That is what Hisban is telling. Okay. उसका फंडामेंटल आंसर है, मैं बताता हूं क्यों. अभी एक थोड़ा ध्यान से सुनो. आपने मेमोरी ऑर्गेनाइजेशन पढ़ा है COA में. उसमें आपने एक छोटा कंसेप्ट पढ़ा है, कैरेक्टरिस्टिक्स ऑफ मेमोरी. आपके सिलेबस में था. मेमोरी, मेमोरी टाइप्स, मेमोरी हायरार्की एंड कैरेक्टरिस्टिक ऑफ मेमोरी, ऐसे था. पॉइंट इज दैट it is correct that my BIU will go to memory via system bus, okay, through address bus, control bus and data bus. It will fetch the instruction. That means my processor is reading instruction from the memory. I'm trying to read from the memory. Which memory? RAM. My processor is reading instruction from memory. Which memory? RAM. And you are well aware some time is required to read from memory. It is called MAT. आपने ये word, ये characteristic पढ़ा है, MAT. MAT stands for memory access time. I am writing little rough. I am writing in speed. MAT stands for memory access time. मतलब क्या कि कितना टाइम लगता है आपको मेमोरी से रीड करने के लिए. That time is much larger than your microprocessor. मतलब होगा क्या कि आप जब तक रीड करोगे तब तक आपका प्रोसेसर को वेट करना होगा, because your processor is a fastest device, but your memory like RAM is comparatively slow. For that, this provision is given. मतलब क्या? Now understand very carefully what is going to happen. By the time your instruction 1 is taken for decode and execute, you are bringing remaining instructions in this queue, because you take time to read instruction from the memory. So what you do, you go on bringing, so that processor will not wait. ऐसे नहीं होगा कि processor is waiting and there is no instruction to decode and execute. We want to reduce waiting time of the processor. For that, this facility called queue is being provided, because there is a gap between speed of memory and speed of the processor. Processor is fast, memory is comparatively slow, and to bridge it we have a queue. मतलब क्या, आप जो भी instructions है वो यहाँ पे रखते जाओ, प्रोसेसर एक एक करके डिकोड एग्जीक्यूट करना चालू करेगा. For that, this queue is provided. Now understand some important characteristic of this queue, because this question may come in your mind. It may happen that processor takes instruction 1 for execution. Okay, see, you can see one arrow which is coming here. मतलब ये instruction 1 आगे लिया, वो execute unit में लिया. See, ये आपका है BIU और आगे है EU. तो हो सकता है कि प्रोसेसर को कुछ टाइम लगे फॉर एग्जीक्यूशन ऑफ द इंस्ट्रक्शन, एंड ड्यूरिंग दैट टाइम दिस क्यू मे बी फुल. ऐसे हो सकता है, मतलब इंस्ट्रक्शन 2, 3, 4, 5, 6 यहां तक इंस्ट्रक्शन आ गए हैं क्यू में. देन इन दैट केस योर BIU विल वेट. अंडरस्टैंड, अगर यहां पे जगह है देन ओनली दैट इंस्ट्रक्शंस विल बी ब्रॉट. It's not like BIU will go on just blindly fetching the instructions. ऐसा नहीं है. If there is a space here, then only new instructions will be brought. And if already previous instructions are waiting, then BIU will stop. It will wait till there is some space that will be created. Okay. And like somebody has said that this is a FIFO queue, that is correct, because you can see instruction 1 you take for decode execute, then instruction 2, then instruction 3. So this is like a FIFO queue. Okay, can we bring this in notebook? Before that, check if you have any questions. Okay, because we have started with architecture. Let's bring those points. So my question is, any questions? Check. Any questions? Check if you have any specific questions. And if you don't have any questions, please reply so that I will come to know that time to go.
No questions, sir.
Okay, okay. I'm just waiting so that if anybody wants to raise, then I will able to answer. ठीक है, नो प्रॉब्लम। अभी हम लोग इसको नोटबुक में लेके आएंगे। तो लास्ट पॉइंट वी रोट वाज पाइपलाइन आर्किटेक्चर ऑफ 8086। ओके, आगे का टाइटल है, नाउ आई एम डिक्टेटिंग फॉर सम टाइम अराउंड 10 minutes. I'm not teaching now. Title is Architecture of 8086 Microprocessor. Architecture of 8086 Microprocessor. Architecture of 8086 Microprocessor. This is the title. Okay, again we will write points. Point 1, 8086 microprocessor. 8086 microprocessor use two-stage pipelined architecture. 8086 microprocessor use two-stage pipelined architecture. 8086 microprocessor use two-stage pipelined architecture such that there are two logical parts. There are two logical parts. There are two logical parts called BIU, bracket bus interface unit. BIU bracket bus interface unit, bracket done, and EU bracket execution unit, bracket execution unit. Okay, point number 1 is complete. Go to second point. BIU is mainly responsible. BIU is mainly responsible to fetch the instruction. BIU is mainly responsible to fetch, FETCH, fetch the instruction, and EU is responsible to decode and execute the instruction. EU is responsible to decode and execute the instruction. Go to third point, point number 3. BIU has a 6-byte instruction queue. BIU has a 6-byte instruction queue such that it can fetch instructions. It can fetch instructions ahead of time. It can fetch instructions ahead of time inside a queue. I repeat entire statement. BIU has 6-byte instruction queue such that it can fetch 6 instructions ahead of time inside a queue. Okay, same point, one more statement. We are talking about queue. This queue is a FIFO queue, FIFO. This queue is FIFO queue. This queue is a FIFO queue such that BIU fills the queue. BIU fills the queue. If you see blue color arrow, BIU fills the queue and EU empty the queue. I repeat, BIU fills the queue and EU empties the queue. Empty means खाली करता है, execution के लिए लेता है तो queue खाली हो जाता है. So it's like one will fill and other will empty. I repeat my last statement. BIU will fill the queue, FILL, and EU will empty the queue, EMPTY. Okay. Now pay attention, because before I dictate this statement, I want to tell you something more. So pay attention. I'm teaching. Okay. I'm not dictating for some time. Okay. What we wrote was, suppose this is my queue. Okay. Observe it. Suppose this is my queue. Then BIU will fill the queue. It will fill the queue with instructions. And EU will empty the queue. So this instruction 1 will be taken for decode and execute, because this is the boundary. You can see this part is EU and this part is BIU. So once you take this instruction 1, this instruction 2 will come at the position of instruction 1, because I said that this is a moving queue. Okay. So my BIU will fill the queue and my EU will empty the queue. That means from this particular queue, your instructions are getting transferred like a flow. There is a flow of instructions. See, 1, 2, 3, 4, 5, 6. Then 1 is taken, 2, 3, 4, 5, 6, 7. Then 2 is taken, 3, 4, 5, 6, 7, 8. Then 4th is taken. That flow is like a water flow in a pipeline. Like there is a water flow in a pipeline. Like that, there is an instruction flow in this queue. And that's why it is called pipelined architecture. That word comes because of this queue. That word pipelined architecture comes because of this queue. Okay, because just like a water flow, there is an instruction flow from this particular queue. 1, 2, 3, 4, 5, 6. Instruction 1 is taken, 2, 3, 4, 5, 6, 7. Instruction 2 is taken, 3, 4, 5, 6, 7, 8. इसका मतलब है, अगर आपने अच्छे से देखा वापस, तो ये देखो, ये इंस्ट्रक्शन 1, ये है इंस्ट्रक्शन 1 का फ्लो, ये है इंस्ट्रक्शन 2 का फ्लो, ये है इंस्ट्रक्शन 3 का फ्लो. And because of this flow, this architecture is called pipelined architecture, because it's just like a flow. And that pipe is basically a queue. Okay. तो हम लोगों को ये स्टेटमेंट लिखना है. तो बैक टू डिक्टेशन. ओके, मैं अभी वापस डिक्टेट कर रहा हूं पॉइंट 3 का लास्ट स्टेटमेंट. ओके, राइट डाउन नाउ. Because this is point 3, last statement. Because there is flow of instructions inside a queue, because there is a flow of instructions inside the queue, because there is a flow of instructions inside the queue, it is called pipelined architecture. It is called pipelined architecture. It is called pipelined architecture. Okay. Now points are complete. We have started with BIU and we talked about a facility called Q. Okay, now we are in the last phase of our today's session. Definitely I'll be using it. The remaining time also I'll be using, because I think in the beginning I said it is like a race against time. So we have to manage it. But before I go ahead, I just want to raise one question again. If you have any queries, any questions, you can get it clarified. Check it out. Any questions are there? Any questions? Okay, I hope there are no questions. It feels that people are getting tired. I can understand, but you have to keep it up for 3 hours, because after that also we will require some extra sessions. Anyway, now I will be only teaching. Okay, we will be only understanding, and we will be creating a background for our next session. Okay, so next around 15 to 20 minutes, you have to only listen carefully. Okay. Type YES. Let me see how many of you are listening. Okay. 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 Great. Fantastic. Keep it up. Okay. अभी सिर्फ समझना है 10-15 मिनट, उसके बाद रुकेंगे. ठीक है. ये प्रोसेसर थोड़ा कॉम्प्लेक्स है. ओके. रीजन इज, if you see my previous slide, typically features. Okay, यहाँ पे. Then you will find one important characteristic, and that is called memory segmentation. Observe it. Okay, that we are going to start, and definitely it is a part of architecture. Exam में हमेशा ये question आता है, explain memory segmentation, direct 10 marks, and sometimes short note, memory segmentation in 886. Okay, so we are only going to start memory segmentation. It is a part of architecture. Let's see what's that. I will go to the architecture again. Okay. I told you that BIU is responsible to fetch the instruction, and EU is responsible to decode and execute the instruction. Okay. I taught what is a queue. I said BIU will go to memory via system bus, this arrow. It will read instruction and it will bring it in queue. And like that, you can bring up to 6 instructions. It is a 6-byte queue. $1 million question is that प्रोसेसर को कैसे पता चलेगा मेमोरी में कहां पे प्रोग्राम है. you will say address bus. बरोबर है. Address bus will tell, because address bus carries location. I have taught you what is the model of memory. So through address bus, processor will find where is my program or instruction in the memory. But problem is the size of this memory is 1 MB. Understand? 1 megabyte. 40 years back. Today we are talking gigabyte. And in the same memory, you are storing program, you are storing data. So we need some memory organization. Okay, क्योंकि आपका प्रोग्राम भी सेम मेमोरी में है और आपके डेटा भी सेम मेमोरी में है. So we need some memory organization. That it's called memory segmentation. Okay, let's understand some basics. What is memory segmentation? So I'm going ahead with memory segmentation. Okay, observe it. Let me erase all this writing. Okay. Now, what is memory segmentation? I told you that 8086 microprocessor supports 1 MB of memory. How this value is coming, that I will show you in our next session. This is where we will continue next Friday. So the maximum memory is 1 MB. Maximum RAM you can use with 8086 microprocessor is 1 MB. What we do, we divide this 1 MB memory into small parts called segment. Observe it. And there are 4 segments. One is called code segment. Second is called data segment. Third is called extra segment. And last is called stack segment. Okay, I repeat again. What we do, how much RAM is supported by 8086 microprocessor? 1 MB. How? That we will discuss in coming session. This 1 MB RAM main memory, you divide in small parts called segment. Okay, how many types of segments are there? 4 types. One is called code segment. Second one is called data segment. Third is called extra segment. And fourth is called stack segment. ये सब important है IA1 के लिए. How many types of segments are there in 8086 processor? 1, 2, 3, 4. 4. What are the types of segment? Some options will be given, combinations. So we have 4 segment types: code, data, extra, and stack. And every segment is 64 KB. Observe it. मतलब हर एक सेगमेंट का साइज कितना है? 64 किलोबाइट्स. KB stands for kilobyte. वो भी predefined है. Now question is why we are doing this type of organization. Okay, I will tell you what is code segment, data segment. We are going for it. उसका reason क्या है? Let's try to understand. Suppose ये मेरा memory है. Okay, ये है मेरा 1 MB का memory. And I'm talking about a program for sorting, SORTING. You know what is sorting. You have studied sorting algorithms, and data structure also you have studied as a subject. तो sorting, अगर मेरा प्रोग्राम sorting का है और मुझे अगर 100 नंबर्स को sort करना है, तो क्या होगा? ये जो मेरा मेमोरी है उसमें प्रोग्राम भी रहेगा, सॉर्टिंग का प्रोग्राम, और मेरा डेटा भी रहेगा 100 नंबर्स। तो हाउ प्रोसेसर विल कम टू नो आपका प्रोग्राम कहां पे है और डेटा कहां पे है, क्योंकि दोनों सेम मेमोरी में है। ओके, सो वी नीड सम मैनेजमेंट। मतलब कैसा है कि यहाँ पे थोड़ा पार्टीशनिंग करने की जरूरत है कि प्रोग्राम कहीं पे रहेगा और डेटा कहीं पे रहेगा, तो प्रोसेसर को पता चलेगा हाँ सॉर्टिंग का प्रोग्राम यहां पे है, सॉर्टिंग का डेटा यहां पे है। दैट वी डू यूजिंग सेगमेंटेशन। लाइक कोड सेगमेंट विल स्टोर योर प्रोग्राम। आपका जो प्रोग्राम है वो हमेशा कोड सेगमेंट में रहेगा। मतलब अगर प्रोसेसर को अच्छे से सुनो मेरा स्टेटमेंट, अगर प्रोसेसर को इंस्ट्रक्शन फेच करना है तो क्या होगा, इंस्ट्रक्शन इज अ पार्ट ऑफ माय प्रोग्राम, बरोबर है? तो वो सिर्फ कोड सेगमेंट में देखेगा, बाकी कहीं पे नहीं देखेगा। देखो कितना लॉजिकल थिंकिंग है, सी। क्योंकि आपका प्रोग्राम कहां पे रहेगा, कोड सेगमेंट में, बाकी कहीं पे नहीं रहेगा। उसके लिए ही आपने ये सेगमेंट बनाए हैं। तो अगर मुझे प्रोसेसर को इंस्ट्रक्शन फेच करना है, हु फेच, बीआईयू फेच करेगा क्यू में। तो इंस्ट्रक्शन अगर मुझे फेच करना है तो मेरा प्रोसेसर मेमोरी में कहां पे जाएगा, सिर्फ कोड सेगमेंट में, और कहीं पे नहीं जाएगा। और उसका साइज कितना है, 64 केबी। मतलब आपका 1 MB मेमोरी में सिर्फ 64 केबी प्रोसेसर देखेगा। दैट्स व्हाई मेमोरी सेगमेंटेशन इज अ माइलस्टोन। हर एक टेक्निक जो 886 माइक्रोप्रोसेसर में यूज किया है, इट्स अ माइलस्टोन। और वो आज भी हम लोग यूज कर रहे हैं, इवन इन मल्टी कोर प्रोसेसर्स i3, i5, i7, और बिफोर दैट पेंटियम प्रोसेसर। पेंटियम also has memory segmentation that actually started in 886. I repeat again, and then we will try to summarize, okay? Because I know you are now at that peak level, and we will try to summarize. But yes, this is a point we will continue next Friday: architecture and memory segmentation. Let me once again go through it, so our next discussion, coming discussion, will be more crystal clear. Memory segmentation is one management technique used on main memory, RAM पे. Memory segmentation main memory पे use होता है. Okay. What is memory segmentation? 1 MB memory supported by processor is divided in small parts called segment. Okay. See this. How many types of segment? 4. Code segment, data segment, extra segment, stack segment. Every segment is 64 KB, always fix. हाई एंड प्रोसेसर में जब हम लोग 80386 में या पेंटियम में जाएंगे, तभी इसमें भी काफी इंप्रूवमेंट है, यू विल सी। बट ये इन 8086 64 KB, 64 किलोबाइट बहुत इंपॉर्टेंट है। IA1 में size of a segment in 8086 microprocessor is dash 64 KB, 128 KB, 16 KB, 8 KB. You should be able to identify 64 KB always. Now question is why we do it. Let's try to understand again. We want to separate our program and data, क्योंकि सेम मेमोरी में मैं मेरा प्रोग्राम भी स्टोर कर रहा हूं और सेम मेमोरी में मैं मेरा डेटा भी स्टोर कर रहा हूं, मुझे वो सेपरेट करना है. दैट इज द मैनेजमेंट. हाउ? अंडरस्टैंड. In code segment, वी स्टोर ओनली प्रोग्राम, जैसे सॉर्टिंग का मेरा प्रोग्राम होगा, दैट आई विल स्टोर इन कोड सेगमेंट, और सॉर्टिंग का मेरा जो डेटा होगा 100 नंबर्स, दैट आई विल स्टोर इन डेटा सेगमेंट. सो आई एम सेपरेटिंग माय प्रोग्राम एंड डेटा. ओके, सॉरी. एडवांटेज, बेटर मैनेजमेंट, क्योंकि आपका प्रोग्राम अलग है, डेटा अलग है मेमोरी में. और सबसे इंपॉर्टेंट, इफ आई गो बैक व्हाट आई टॉट, when your BIU will fetch instruction from the memory, this memory is 1 MB, don't forget. Okay, then you are fetching instruction. Instruction is a part of a program, and program is always in code segment. So my processor don't have to look in this entire 1 MB. It will only look for 64 KB. That 64 KB is code segment, and effect is time to locate your program in memory will be less, क्योंकि 1 MB में देखना और 64 KB में देखना 100% there is a difference. 1 MB मेमोरी में देखना मेरा प्रोग्राम कहां से चालू हो रहा है, और 64 KB मेमोरी में देखना there is a difference. I'll tell you how it is different. 64 KB को अगर आपने 16 से मल्टीप्लाई किया, 64 KB इंटू 16 16, तो आपको 1 MB मिलेगा. मतलब आप जो सर्च कर रहे हो वो इतना छोटा जगह होता है 64 KB, 16 टाइम लेस. That's why this memory segmentation is important, क्योंकि यहां पे when you fetch you will only look for code segment. आपको पूरा मेमोरी देखने की जरूरत नहीं है. Okay, I'll tell you one simple example. If you are trying to read a book with 1000 pages, and if you want to read some specific page or specific matter, तो आप क्या करते हो, आप पहले इंडेक्स देखते हो चैप्टर कौन सा है, and then directly you go there. Like that, here we do using memory segmentation. Okay, now this we will continue in our next session. I think we are in last 5 minutes. So last time, question to everybody. If you have any specific query, any suggestions, you can give, because this is our start session. So if you have any queries, if you have any questions, any suggestions, you can tell me, or you can ask any questions. Check it out. You can unmute and talk to me. Maybe you can use chat box, whatever you prefer. All suggestions are welcome. Yes, what is your reply? Any questions? No questions. Yes, Bilal, that's a good question. Why only 1 MB? But I think better that we start this discussion in next session, Friday. But I will tell you simple answer. It is 1 MB because how much memory is supported by your microprocessor is decided by address bus. So address bus will decide how much memory is supported by your processor, and size of address bus in 8086 is 20 bit, and with that 20 you can only refer 1 MB. How? That calculation I will show you in coming session. That's the answer to you, Bilal. और मैं आपको नेक्स्ट सेशन में ये भी बताऊंगा कि हम लोग आजकल ऐसे बोलते हैं मेरा 4 GB सपोर्ट है, रैम 8 GB सपोर्ट है, वो कैसे आता है वो भी मैं आपको बताऊंगा. वो पूरा टेक्निकल है, समझा तो इट इज समथिंग लाइक वर्क, लेकिन अगर नहीं समझा तो इट बिकम्स जस्ट अ रैंडम, इट इज लाइक दैट, वी विल सी इन कमिंग सेशन। ओके ठीक है, तो शायद कुछ क्वेश्चंस नहीं है, बिकॉज आई डोंट सी एनी फर्दर क्वेश्चंस कमिंग। 2-3 points I just want to repeat before we end for the day. That was a great session. I can continue teaching for next 3 hours also, but anyway, सबसे important उसका जो डिटेल्ड नोट्स है, मैं आपको एक क्विक रेफरेंस के लिए आपको नोट्स दे रहा हूं, सो दैट यू कैन गो थ्रू इट क्विकली। बट इसका जो डिटेल्ड नोट्स है दैट यू विल बी गेटिंग, दे आर माय नोट्स ओनली, मॉड्यूल 1, 2, 3, 4. Okay, and once you see, hopefully when we meet next Friday, before that you can see those notes well organized there. That will be your main reference. मॉड्यूल 5-6 का इन प्रोग्रेस है, क्योंकि बहुत स्पेसिफिक है वो मॉड्यूल्स, आपको सब कुछ नहीं पढ़ना है। नंबर 2, प्लीज revise and then you come for next session, consecutive session, because I have a question of us, I have a habit of asking questions. Okay, those who were in COA, they are well aware ki how I start consecutive sessions. So revise, come, so that you are answerable. Your contribution is very important. I must understand your understanding. 3, syllabus is huge, HUGE, large. Lesson plan is for 10 sessions. It's ready, you will get it. But we may have to go 1 or 2 extra, because it's a complete package called microprocessor from AT86 going till Pentium. Okay, so these are some gentle reminders. Anyway, for session 1, that's all from my end. That was a great session. So I'm ready to close the session. Have a nice weekend and take utmost care. That's important. I'm conducting the session from home, so I'm not wearing the mask. But otherwise, we have to take care of ourselves. Okay, take care and have a good night. Thank you so much.
Thank you, sir.
Yes, thank you. Keep studying and participate.
Thank you.
So will
Okay.
this,
Yeah, go ahead, I'm listening.
so will this SEM be online or offline?
I think most probably it will be online, because again I have heard ki today there was some meeting and all that, but it seems difficult because suddenly so many people may not come together. So mostly it will be online, or it will be 70% online and 30% offline. That is maximum possibility.
Okay, sir.
Which book to refer? Yes, Douglas Hall. You can start with Douglas Hall. That's the fantastic textbook. I like it. Or I will tell you some more books also, but start you can do with Douglas Hall. And our notes are great. When you see, you will find it that it is proper stepwise notes. माइक्रोप्रोसेसर के पहले 4 मॉड्यूल्स के नोट्स का कोई प्रॉब्लम ही नहीं, क्योंकि मैंने वो खुद बनाया। मेरे जब भी नॉर्मल क्लासरूम टीचिंग था, तो वो जो डिक्टेट करता था उसका नोट्स है, एकदम ये है कॉम्पैक्ट एंड वेल मेड, 1 2 3 4. Anyway, let's end for the day. Let's continue next Friday.